Hello and welcome to today's lesson on understanding the resistance variation in a diode and recognizing its IV graph. Today we will discuss how and why diodes are non-ohmic conductors. We will then dissect and analyze the IV graph for a diode. So far, you are familiar with Ohm's law and the IV characteristics of ohmic conductors and filament lamps. Let's see how diodes compare. As mentioned in our lesson on common circuit components, a diode is like a one-way street for electrons. When current flows in the direction of the arrow symbol on the diode's resistance is very low and current can flow through easily. However, when the current flows in the opposite direction, the diode has a very high resistance and doesn't allow the current to flow through. Diodes are non-ohmic conductors, which means their resistance isn't constant. They do not follow Ohm's law as their resistance differs significantly, depending on the direction of the current. Let us now examine how this behavior is shown on their current voltage IV graph. Unlike an ohmic resistor, which has a linear IV graph, a diode has a nonlinear IV graph. When voltage is applied in the direction the diode allows, it conducts current readily. Since the gradient is 1 divided by R, the gradient of this part of the graph is very steep, and the graph has a steeply rising curve on the IV graph for positive voltages. In contrast, when voltage is applied in the opposite direction, the diode exhibits very high resistance and conducts minimal current. Hence, on the IV graph, you would see a horizontal line in the negative voltage region, indicating practically no current conducted. An important characteristic to note is that in the forward direction, the current doesn't start rising immediately. Instead, it begins to rise significantly only after the voltage surpasses a certain level, typically around 0.7 volts. This specific voltage is known as the threshold voltage. Beyond this point, the diode starts to conduct current much more easily. The 0.7 volt threshold voltage is a characteristic feature of diodes and is determined by the structure of semiconductor materials, though this is beyond the bounds of GCSE physics. However, if interested, it provides a great area for further exploration. Understanding the IV characteristics of a diode is not just a theoretical exercise. It has many practical applications in the real world. Diodes are used in various electronic devices and systems due to their ability to control the direction of current flow. For instance, diodes are used to convert alternating current, AC, into direct current, DC, which is essential for powering most electronic devices. Diodes also play a crucial role in protecting electronic devices from sudden voltage spikes, which could otherwise damage sensitive components. By understanding the behavior of diodes, engineers can design and optimize a wide range of electronic systems, from simple battery chargers to complex communication devices. In today's lesson, we examined how the electrical resistance of a diode varies and how this is graphically represented on an IV current voltage graph. We learned that a diode is a device that allows current to flow in only one direction while blocking it in the reverse direction. By understanding these characteristics and the shape of the diode's IV graph, we can better appreciate how diodes function in circuits to control the direction of current flow. By knowing how diodes work, you gain insight into the technology behind many of the gadgets and systems you use daily,